Thank you for coming back and watching our 10th video on integration. This video is going to be discussing integration by parts, and to introduce integration by parts I'm going to start off with a review of differential calculus. So I'm going to start off with the product rule. For two functions, u of x and v of x, we can define the derivative of u times v is equal to u dv dx plus v du dx. If we were to get rid of these dx's and turn it into its differential form, duv is equal to u dv plus v du. And then we integrate both sides. We then get our integral. So we integrate this, and we simply end up with uv is equal to the integral of u dv plus the integral of v du. So let's just bring our integral of v du over, and we can define that the integral of u dv is equal to u v minus the integral of v du. That's the derivation of the equation for integration by parts, and it's best seen through example. So let's just rewrite this up here. U dv is equal to uv minus the integral of v du. Okay, so as a simple example, the integral of x e to the 5x dx. So other than looking at an integral table, we really can't evaluate this. But by using integration by parts, we can actually obtain the integral table. And in fact, a lot of the integral table integrals are determined by performing integration by parts. So in this example, we can set u is equal to x. Du is equal to dx. So here we have u is x, and we can define this as dv. So dv is equal to e to the 5x dx. So v is simply just the integral of this, which is 1 over 5 e to the 5x. And we can leave out the c because we're going to be combining the c's later on. So our new expression. So this is equal to u x times v 1/5 e to the 5x minus the integral of v 1 over 5 e to the 5x times du dx. Okay, so let's just rewrite this. 1/5 x e to the 5x minus 1/5 the integral of e to the 5x dx. This integral, we've already evaluated this. It's 1/5 e to the 5x plus c. And we can just absorb the 1/5 into the c. So we end up with 1/5 x e to the 5x minus 1/25 e to the 5x plus c. And if we were to do an integral table, we would see the same thing. We would see the same result. So in our next example, we haven't actually been able to derive the integral of the natural log of x. This also appears in the integration table, but let's see how one obtains this integral. Now the only thing is that x has to be greater than 0, because anything less than or equal to 0 cannot, you can't obtain the logarithm of anything that's less than or equal to 0. So here, u is equal to the natural log of x, and du is equal to 1 over x dx. dv is simply just dx, and v is equal to x. So evaluating this integral, it's equal to it's equal to u, which is natural log of x, times v, which is x, minus the integral of v, which is x, du, 1 over x dx. So we have x log of x minus the integral of dx, which is x plus c. So we get x log of x minus x plus c. So this becomes our integral table entry for the integral of natural log of x, once again assuming that x is greater than 0. Now the final integral that we're going to evaluate is the integral of sine of x cosine x dx. So here's an example of where we get a cyclic integral. By cyclic I mean, well, we'll see what I mean. Where u is equal to sine of x and du is equal to cosine of x dx. dv is equal to cosine of x dx, and v is equal to sine of x. Once again, just finding the integral of dv. So here we have u is sine of x, v is sine of x, minus the integral of v sine of x times du cosine x dx. So let's just rewrite this out. The integral of sine of x cosine x dx is equal to sine squared of x minus the integral of sine of x cosine x dx. We have the same integral on both sides of the equation. So we can bring that integral over and add them together. So we have 2 times the integral of sine of x cosine x dx is equal to sine square of x plus c. Let's not forget the c. Divide by 2, and we get the integral of sine of x cosine x dx is equal to sine squared of x over 2 plus c. And just to make sure that this is a valid technique, we're going to find the derivative of sine squared of x over 2. So the derivative of sine squared of x over 2 is equal to 1/2 times the derivative of sine of x squared. Let's say we let u is equal to sine of x, so it's equal to 1/2 du dx, du squared dx. So that equals 1/2 times 2u times u prime, according to the chain law. So it's equal to sine of x, u prime, cosine of x. Confirmed. So thank you once again for watching this video on integration by parts. I look forward to seeing you guys back in our next video. Thank you for watching.